Jai Jagannath, welcome to our YouTube channel. Today we are going to discuss about 2021 previous year JAM question. Section A. So first question is, let 0 less than alpha less than 1 be a real number. The number of differential function y 0 1 to infinity having continuous derivative on 0 to 1 and satisfy y dash t equal to y t to the power alpha when t belongs to 0 to 1 and y 0 equal to 0 it is given condition. Now y dash t we can write dy by dt equal to y to the power alpha implies dy by y to the power alpha equal to dt implies y to the power minus alpha dy equal to dt. Take integration both sides. Now x to the power n dx integration equal to x to the power n plus 1 divided by n plus 1 plus c. Now y to the power 1 minus alpha divided by 1 minus alpha equal to 3 plus c. Now given condition is y 0 equal to 0 implies when t equal to 0 then y equal to 0. Then now when t equal to 0, so 0 to the power 1 minus alpha divided by 1 minus alpha equal to 0 plus c implies 0 by 1 minus alpha equal to 0 plus c implies c equal to 0. That means okay, y 1 minus alpha divided by 1 minus alpha equal to 3 c equal to 0. This is the solution. Now the solution is depending upon t. When t varies then y also varies. Implies y to the power 1 minus alpha equal to 1 minus alpha into t implies y equal to 1 minus alpha whole into t to the power 1 by 1 minus alpha. So this is infinite solution. Now next question. Given that let p from r to r be a continuous function so that p is greater than 0 for all x belongs to r. Let y be the twice differentiable function satisfying y double dash x plus px y dash x minus yx equal to 0. Now for all x belongs to r, suppose there are two rational number a and b so that a less than b, y of a equal to y of b equal to 0. Now but given that 3 from r to r is a continuous and px greater than 0, let px equal to 1 constant function which is greater than 0 and also continuous function. So I can take now differential equation is y double dash plus y dash minus y equal to 0, which we can take from auxiliary equation is m square plus m minus 1 equal to 0. Now m equal to minus 1 plus minus b square minus 4ac root over. So b square is 1 minus 4ac, 4 into 1 into minus 1 plus 4 root over divided by 2a. So 2. Then am equal to plus minus minus 1 plus minus root 5 divided by 2 equal to minus 1 by 2 plus minus root 5 by 2, which is in the form of alpha plus minus root beta. We have formula: if am equal to alpha plus minus root beta, then yx equal to e to the power alpha x whole into c1 cos root beta x plus c2 sin, not root beta, cos hyperbolic root beta x plus c2 sin hyperbolic root beta x. Now the given solution is here alpha equal to minus 1 by 2, so e to the power minus 1 by 2 x c1 cos hyperbolic root 5 by 2x plus c2 sin hyperbolic root 5 by 2x. Now given boundary condition is y equal to a implies e to the power minus 1 by 2a c1 cos hyperbolic root 5 by 2a plus c2 sin hyperbolic root 5 by 2a equal to 0. And again y of b also 0. That means e to the power minus 1 by 2 b c1 cos hyperbolic root 5 by 2 b plus c2 sin hyperbolic root 5 by 2 b also equal to 0. Now exponential function can't be 0 for any value of a. That means c1 cos hyperbolic root 5 by 2a plus c2 sin hyperbolic root 5 by 2a equal to 0. And again this function also not equal to 0. That means c1 cos hyperbolic root 5 by 2a plus c2 sin hyperbolic root 5 by 2, sorry not a, b equal to 0. Let this is equation 1 and this is equation 2. From these two equation we can write it like this: cos hyperbolic root 5 by 2a sin hyperbolic root 5 by 2a cos hyperbolic root 5 by 2b sin hyperbolic root 5 by 2b c1 c2 equal to 0. It's 0 to 0. Now this is in the form of ax equal to 0, which is system of equation, and we know in this system of equation there are two solutions if determinant of a not equal to 0 and determinant of a equal to 0. If determinant of a not equal to 0, then it have a unique solution which is only x equal to 0. If determinant of a equal to 0, then it has infinite solution. Now if c1 c2 have non-zero solution, then we have to, then this matrix determinant must be have to 0. That means if c1 and c2 are not trivial solution, then cos h root 5 by 2a sin h root 5 by 2a cos h root 5 by 2b sin h root 5 by 2b determinant must be 0. That means equal to determinant is this minus this. So cos hyperbolic root 5 by 2a into sin hyperbolic root 5 by 2b minus cos hyperbolic root 5 by 2b into sin hyperbolic root 5 by 2a equal to 0. Now take this portion other side. That means cos hyperbolic root 5 by 2a into sin hyperbolic root 5 by 2b equal to cos hyperbolic root 5 by 2b into sin hyperbolic root 5 by 2a. Now take cos hyperbolic to this and interchange between. Now this implies sin h root 5 by 2b divided by cos h root 5 by 2b equal to sin h root 5 by 2a divided by cos hyperbolic root 5 by 2a implies tan hyperbolic root 5 by 2b equal to tan hyperbolic root 5 by 2a. That is, this tan hyperbolic is increasing function. So if function are equal, that means root 5 by 2b equal to root 5 by 2a. Implies b equal to a equal to b, which is not possible. Because given that a less than b, so there can't be a equal to b, so the function are not equal, so its determinant is not equal to 0. Now if determinant is not equal to 0, that means c1 c2 are trivial solution. That means c1 equal to c2 equal to 0. So y equal to e to the power minus alpha x c1 cos h root beta x plus c2 sin hyperbolic root beta x. If c1 c2 are 0, that means y equal to 0. This is the only solution. Number 3. Given that if f from r to r be a continuous function satisfying fx equal to fx plus 1 for all x belongs to r, given that fx equal to fx plus 1 for all x belongs to r, then option A, f is not necessarily bounded above. Now let fx equal to c, which is any constant function, then fx equal to fx plus 1 for all x belongs to r, which is satisfy this condition. But now c is bounded function, so bounded means it has both bounded above and bounded below. But option A, given that fx is not necessarily bounded above, so option A false. Now option B, given that there exists unique x belongs to r such that fx not pi equal to fx not. Now let f of x equal to c, so f of 1 equal to c, f of 1 plus pi also c, again f of 2 equal to c and f of 2 plus pi also c. There exists 2, but given that there exists unique x naught, so Option B also false. Similarly, there is no x not belongs to R. Option C. From B, option C also false. Now, option D. There exists infinitely many x naught. Option D right. There is infinite. Now, number 4. Number 4. Given that let f from R to R be a continuous function such that for all x belongs to R, given that f h t dt from 0 to 1 equal to 0. Now, take derivative both sides. D by dx 0 to 1 fx p dt equal to d0 by dx implies now if function is fx t dt f1x to f2 f1 to f2 then fx then f dash x equal to del f by del x xt f1 to f2 dt plus f x f2 t into d of f2 t by dt minus f of x f1 t into d of f1 t by dt. This is called Leibniz rule. Leibniz rule. So by this rule, its derivative is del f by del x dt 0 to 1 plus f of 1 x into 1 into derivative of 1 is 0 minus f of x into 0 into derivative into 0 equal to 0 implies del f by del x dt 0 to 1 equal to also 0. Now del this f is xt given that now this is f dash xt into x by chain rule into dt divided by 0 to 1 equal to 0 not x t. Now f of x t dt 0 to 1 equal to e f dash x t dt 0 to 1 equal to 0. That means f of x t equal to 0 and f dash x t equal to 0. If function is 0 and its derivative also 0, then it is identically 0. That means f equal to identically 0. So option A 2. Now for number 5, given that let p and t be a positive real number, p t greater than 0 and belongs to R. Let dt be a closed disk of radius t centered at origin. Dt given that dt equal to xy belongs to r square such that x square plus y square less than equal to e square less than equal to e square. That means centered origin means center is origin, radius is t. Now given that IPT equal to dx dy divided by x square plus y square plus p square whole into p double integration. Now by Jacobian we can write this like dx dr equal to d dr d theta divided by x square plus y square. Let x equal to r cos theta, y equal to r sin theta by Jacobian. So x square plus y square equal to r square cos square theta plus r square sin square theta equal to, if I take common, then cos square theta plus sin square theta equal to r square. So x square plus y square equal to r square. So r square plus p square whole into p. Now take limit from r 0 to t. Radius is 0 to t, and theta moving totally 360 degree implies 2 pi. So theta is 0 to 2 pi. Now this is 1 by 2 r square plus p square 1 minus p divided by 1 minus p 0 to t d theta 0 to 2 pi equal to 1 by 2 1 minus p. Put t, then it's e square plus p square whole into 1 minus p minus p square whole into 1 minus p into d theta which is 0 to 2 pi. Now equal to, this is 2 pi by 2 1 minus p into p square plus p square 1 minus p minus p square 1 minus p. Now IPT equal to y by 1 minus p square plus p square whole into 1 minus p minus p square whole into 1 minus p. Now given that limit IPT from t tends to infinity equal to finite, then we have to find the value of p. Now let p equal to 1, then pi by 0 into p square plus 1 0 minus 1 to the power 0, which is infinity, not finite. So p can't be 1. Now let p less than 1. If p less than 1, then p minus 1 less than 0. That means we can take p minus 1 equal to minus alpha and alpha greater than 0, we can write, that means implies 1 minus p equal to alpha, where alpha is greater than 0. Now I treat p equal to by alpha p square plus p square alpha minus p square by alpha. This is greater than 0. This also greater than 0. If at a limit I t tends to infinity, then this is tends to infinity. Alpha greater than 0, pi greater than 0. This also greater than 0. That means this is unbounded. Unbounded means not finite. Now last chance, let p greater than 1. That means p minus 1 greater than 0. Let p minus 1 equal to alpha when alpha greater than 0. 1 minus p equal to minus alpha, alpha greater than 0. Similarly, when we put this value in this equation, then we get I p equal to pi by minus alpha into p square plus p square minus alpha minus p square by minus alpha, implies I p equal to alpha by minus alpha 1 by t square plus p square minus 1 by t square. If limit of I p tends to infinity, then this portion tends to 0. This is minus alpha 0 minus 1 by p square. P is any real number and positive number and fixed value. Then this is finite, so this is finite. So for p greater than 1, we can find limit of I p t tends to infinity. Now next number, given that how many elements of the group Z50 have order 10, Z50 have order 10. We have to remember this thing in Zn. If D divides N, then there have 5 D elements of order D in Zn. Now 10 divides 50, then means how many elements are there? 5, 10, which is equal to 5 of 2 into 5 equal to 5 of 2 into 5 of 5 equal to 1 into 4 equal to 1. So there are 4 elements of order 10. Now next question, given that for every n belongs to capital N, let fn from R to R be a function from the given choice with the statement that is the negation. Given statement is for every x belongs to R and for every real number epsilon greater than 0, there exists an integer n greater than 0 such that summation of f n plus 1 x less than epsilon I equal to 1 to p for all p greater than 0. Now we have to write its negation statement. So in negation we have to change similarly, like for every to there exist and there exist to for every. Here for every x, for every epsilon, here is there exist n, and for p. So we have to change there exist x belongs to r and there exists epsilon greater than 0 such that for all n greater than 0 this is less greater than equal to epsilon. For there exists p greater than, like there exists epsilon greater than 0 and x belongs to r and epsilon greater than 0 such that for all n greater than 0 there exists p greater than 0 such that summation of n f plus 1 x less than epsilon I equal to 1 to p. So option C is true. Now, next question. Given that which one of the following subset has a non-empty interior point? Let S be any set non-empty, A be the interior point of S if there exists epsilon greater than 0 such that A minus epsilon, A plus epsilon is containing in S, that is interior point. Now option A, given that set of all irrational number, let A be set is irrational number. Let A belong to S. Now A minus epsilon, A plus epsilon does not contain in S because in between this interval there are a lot of rational number also. A minus epsilon, A plus epsilon intersection Q not equal to 5. So this is not interior point. Thus this set is not interior point. So non-empty interior set means open set. If S is open, if and only if interior bit B equal to given set if A belongs to R such that sin A equal to 1. If sin A equal to 1, then A equal to like pi by 2, 3 pi by 2, 5 pi by 2, 9 pi by 2, like this. So this set is not open. If interior, similarly D given that set of rational point. like option A, D also false. Because similarly we can show that if A belongs to S and S be the rational number, similarly A minus epsilon and A plus epsilon does not contain in S. If only we change the rational number, na? Rational number. Now option C. Given that B belongs to R such that x square plus bx minus 1 equal plus 1 equal to 0. This set if has a distinct root. Now x square plus bx plus 1 equal to 0, x equal to minus b plus minus b square minus 4 root over divided by 2. For distinct root, b square minus 4 not equal to 0. Now b square not equal to 4. That is b square not equal to plus minus 2. B not equal to plus minus 2. That means b can be minus infinity to minus 2 union minus 2 to 2 union 2 to infinity. Now we know that union of finite open set are open, arbitrary open set also open. So B is open set, and by the definition we know in open set every point has its interior point. So B interior equal to B.